Hello, class.
Welcome to Automotive Electrical Inspection and Maintenance class. Fire acts promptly, harnesses energy, seizes the moment, and proactively takes the initiative to attack. Be a time manager, for only you can. Choose your own direction. In this lesson, we will study an overview of the ignition system, primarily focusing on three aspects: the functions of the ignition system, the requirements for the ignition system, and the classifications of the ignition system. The purpose of the ignition system is to timely provide a spark of sufficient energy for the compressed combustible mixture inside the cylinders of a gasoline engine, allowing the engine to combust rapidly and perform work. The requirements for the ignition system include 1. Achieving breakdown voltage, where the ignition system can generate high voltage capable of sparking across the spark plug gap. The principle behind the electric spark is that, in a normal state, a small number of gas molecules in any gas are ionized into positive ions and electrons. These electrons may exist independently or combine with neutral molecules to form negative ions. When a voltage is applied across the positive and negative electrodes, under the influence of the electric field, the positive ions between the electrodes move towards the negative electrode, and the negative ions and electrons move towards the positive electrode. The movement of ions and electrons collides with neutral molecules, forming a current. The factors affecting breakdown voltage include the spark plug electrode gap, pressure, and temperature of the mixture in the cylinder, electrode temperature, electrode polarity, and operating conditions of the spark plug. 2. The electrical spark energy, used to bridge the gap between the spark plug electrodes, should possess sufficient energy. When the high-voltage electricity jumps the gap between the electrodes, its electrical energy is converted into thermal energy, igniting the combustible mixture. In order to reliably ignite the mixture, the electrical spark across the spark plug electrode gap must have sufficient energy. The larger the spark energy, the easier it is to ignite the mixture, resulting in better engine combustion performance. Conversely, if the spark plug energy is lower, the ignition performance will be poorer. 3. Accurate ignition timing allows the ignition to adapt to the engine's operating conditions. 1. Revolutions per minute, RPM, and load. The higher the engine RPM, the larger the optimal ignition advance angle should be. 2. Startup and idle. When the engine is in startup and idle conditions, although the combustion speed of the mixture is slow, the total combustion time of the mixture occupies only a small portion of the crankshaft angle. 3. Fuel quality. 4 others. There are many factors that affect the optimal ignition advance angle, such as the air-fuel ratio of the mixture, engine intake pressure, and coolant temperature. There are 3 main methods of classifying the ignition system. 1. According to the power source of the ignition system, there are magneto-ignition systems and battery ignition systems. Classified based on the storage and ignition energy delivery method, there are inductive discharge ignition systems and capacitive discharge ignition systems. 3. Classified based on the device triggering the ignition signal in the low-voltage circuit, there are 1. The traditional ignition system, also known as a battery ignition system, is controlled by the contact points of a breaker to control ignition and the opening and closing of the primary circuit. This system is now obsolete. 2. The electronic ignition system primarily utilizes semiconductor devices, such as transistors and thyristors, as switches, to control the ignition coil and interrupt the primary current, thereby accomplishing ignition. It is divided into 2 main types: contact-assisted transistor ignition systems and contactless electronic ignition systems. 3. The microcomputer-controlled ignition system, also known as the computer-controlled ignition system, is controlled by a computer based on input signals from various sensors, and it manages ignition and the opening and closing of the primary circuit through computation and processing. It is divided into 2 main types: distributor-based microcomputer-controlled electronic ignition systems and distributorless microcomputer-controlled electronic ignition systems. This concludes all the content of this lesson. Thank you for watching.